This is another video in our series of videos in which we're looking at solutions to the CSEC physics paper from 2024 exam from earlier today. All right, so we reach question 3, and question 3 deals with heat. Now, question 3, part A, says using arrows, match each mode of heat transfer to one correct description. So, we must pay attention to the instructions in questions in order to do well. Even if we find more than one description which actually matches a particular mode of heat transfer, the question specifically says that we're supposed to match it to one, right? So we're supposed to match each mode of heat transfer to one correct description. So what we probably should do is to find the one which is the most appropriate and match it to that, right? So let's speak about conduction and let's see which of these properly matches conduction. Transfer by medium movement. During conduction, does the medium move? The answer is no. Can conduction take place without a medium? No. Does conduction transfer or take place, or does conduction involve the transfer by electromagnetic wave? No. Transfer without medium movement? Yes. Transfer by physical contact? You can also say yes. Transfer through liquids and gases? We know gases don't readily conduct heat. While they can, they're very poor conductors. Liquids are poor conductors of heat, but they can conduct. So that one would not necessarily be the most appropriate. So we can say transfer by physical contact, or we can even say transfer without physical movement or without medium movement. Either of those should be acceptable. All right. So we'll draw a line from conduction to transfer. Let me put by physical contact, right? By physical contact. But we easily could have said transfer without medium movement as well, right? Let's talk about convection. Does convection take place with a medium movement? Actually, it does, yes. Does it take place through liquids and gases? Yes, it does. But because we only want to match one, let's match this convection to say transfer through liquids and gases, right? But we could easily have matched to say transfer by medium movement because during convection, the fluid, which is the liquid or the gas, will actually move. We know that convection takes place due to the circulation of the fluid, where typically the warm, less dense fluid will rise and then the heavier, denser fluid will then sink. And this basically sets up a convection current. So we easily could have matched convection to transfer by medium movement, right? Could have matched that one as well. Radiation, transfer by electromagnetic wave. That is probably the most obvious one there. Transfer by electromagnetic wave, okay? Yes. All right, so if you're able to do that, then you should have gotten those 3 marks. All right, figure 7, part B. Now, part B, figure 7 shows a section of a solar water heater which utilizes a greenhouse or the glasshouse effect in its operation. So we have some insulation, and of course, you have some copper tube or copper pipes through which, of course, water will flow. I have some insulation. We have a glass cover or a glass plate, which, of course, is there for the purpose of the greenhouse or the glasshouse effect. And we have black collector plate, right? It says briefly describe the greenhouse or the glasshouse effect. So let's talk about a greenhouse, right? So let's say we have a greenhouse, right? We have a greenhouse. And of course, that is the roof of the greenhouse, which is made of glass, right? So inside this greenhouse, we have plants. Let me see if I could draw a tree. Well, it doesn't look like a nice tree, but we have plants in the greenhouse, right? We have plants in the greenhouse and so on. We have some plants on maybe hanging up so right, but we have plants in the greenhouse, right? We have plants. Now, what is going to be happening here? We know that of course the sun is here in out in all her glory, right? So the sun is there in out in all her glory, right? And from the sun, of course, is coming radiation of different wavelengths. The sun might be emitting visible radiation and of course some form of infrared as well. And this radiation is going to be passing through this greenhouse, right? So the radiation from the sun comprising, say, visible light, infrared, is going to be passing through the roof of the glass roof of the greenhouse. Now, what happens to the radiation when it actually enters the greenhouse? When it enters the greenhouse, some of this radiation, all right, so this one looks a little bit different. Some of this radiation will be absorbed by some of the plants, right? Some of the radiation will be absorbed by the ground in the greenhouse. And what happens is that the ground or the earth, because it absorbs some of the radiation, its temperature will increase. Now, because its temperature will increase, it will then emit some of this radiation. But of course, the temperature of the ground inside the greenhouse and also the temperature of the plants is very much lower than the temperature of the sun. And what happens is that the radiation being emitted by the plants and by the ground is of a much longer wavelength. They're of a much longer wavelength, and as a result, they do not possess enough energy to escape through the glass of the warehouse. So that radiation basically becomes trapped within the greenhouse, and it therefore what's what I'm looking for? It contributes to an overall high average temperature of the greenhouse, right? So basically, this trap radiation, which cannot escape due to its longer wavelength, contributes to the constantly high or the warm temperature of the greenhouse. And that basically summarizes how the greenhouse effect takes place, right? Now, let's move on to part two of the question. Part 2 says of Part B, the energy absorbed from the sun by a solar water heater is 360 kilojoules. Let's write down that value. So the energy absorbed, so E absorbed is equal to 360 kilojoules, right? 35% of the energy is transferred to 1.5 kilogram of water in the pipes. So 35% of this energy, now 35% is the same thing as 0.35. So we can say 0.35, or let me just do this way first, 35%. So we have 35 over 100 times 360 kilojoules, which of course is equal to 0.35 times 360 kilojoules, right? 0.35 times 360. Let's see what that gives us. 0.35 times 360. So that's 126. So this gives us 126 kilojoules, which of course is the same thing as 126,000 joules. So this amount of heat energy is actually transferred to 1.5 kilogram of water in the pipes. And they want us to find or to calculate the final temperature of the water if its initial temperature is 30 degrees Celsius. So we have the mass of the water. The mass of the water, M, equals 1.5 kilograms. We have the specific heat capacity of the water, which is given as 4,200 joules per kilogram per Kelvin. I mean, they're given it as per degree Celsius, but we're talking about temperature changes. And when it comes to a temperature change of 1 degree Celsius is the same as a temperature change of 1 Kelvin, right? Yes. And of course, we have the initial temperature of the water, let's call that T1, which is equal to 30 degrees Celsius. Now, in terms of the energy being absorbed by the water, this energy is given by the formula E is equal to mc delta T. We have the total energy, which is 126,000 joules. We have the mass, and we have C, and therefore we can find the change in temperature, delta T. So let's go ahead and do that. So say that 126,000, so 126,000 joules, right? So 126,000 joules is equal to the mass, which is 1.5 kilograms, 1.5 times 4,200 times the change in temperature, delta T. So we say that 126,000 is equal to, what is 1.5 times 4,200? That looks like 42 plus 21, 6,300. And this is times delta T. And therefore what this means is that delta T, my cursor, I can't see my cursor, oh, right. So delta T, the change in temperature, is equal to 126,000 joules divided by 6,300 And this, of course, would be mm, well, the joule per whatever the unit is. Huh? Um, so yeah, take out the joules. That would be mass kilogram times specific capacity. So this is the joule per Kelvin, right? So joule per Kelvin. So therefore, we see that delta T is equal to 126,000 divided by 6,300. That actually looks like 20. So delta T is equal to 20 Kelvin, or we can say 20 degrees Celsius, because it will be the same because we're talking about temperature change. But of course, if we come back over here, we see that T1 is equal to 30 degrees Celsius, the initial temperature. And because heat is being transferred to the water, then it's going to experience a temperature rise, right? And so therefore, if we let the final temperature be T2, we can say that T2 minus T1 would be equal to the delta T, which is 20 degrees Celsius. And so T2 minus 30 degrees Celsius is equal to 20 degrees Celsius, which therefore means that T2 equals 20 plus 30, and the final temperature T2 is equal to 50 degrees Celsius, right? So with this heat energy being absorbed by the water, then it experiences a temperature rise of 20 degrees Celsius. But if the initial temperature was 30 degrees Celsius, that means the final temperature is 50 degrees Celsius. All right? Now, the last part of the question is qualitative in nature. It requires us to actually explain something and not do a calculation. So the next part of the question says, explain why copper or why the pipes or tubes are made from copper. So in other words, what are the properties of copper which allow them or which make them suitable for use in the solar or the water heater for use as a pipes or tubes? Now we know that copper has a very good thermal conductivity. In other words, then they are very good thermal conductors, or we can say that they conduct heat very well. And as a result of that, copper pipes are suitable for use in a solar water heater. Now, of course, we know that whenever we have water flowing through any metal pipe, there should be cause for concern where corrosion is concerned, right? Right. So if we have metal pipes which are carrying water, then we should be concerned about corrosion. Unfortunately, copper does not corrode easily. So we could say it is somewhat corrosion resistant. And therefore, this also helps to make copper suitable for use as the pipes or the tubes in the solar water heater, right? So this was question 3 from CSEC Physics from 2024. And in all honesty, it wasn't a very challenging question. It requires us to basically match the three modes of heat transfer to one correct description, and also to describe or to explain briefly describe the greenhouse effect and do a little calculation, which wasn't exactly very challenging, and also to explain why copper pipes are used in solar water heater. So overall, it wasn't a very challenging question.